Good afternoon, everyone. Welcome to the parallel session of the International Conference on Advancement in Data Science, E-Learning and Information System, or ICADEIS 2025. My name is Ridwan Andrianou, and I am honored to serve as the moderator for this section. Today, we have a series of remarkable presentations that will explore the sub-theme of e-learning. Before we begin, allow me to outline the format for this session. Each presenter will have 10 minutes to deliver their presentation. At the 8th minute mark, there will be a reminder that there are 2 minutes left. And at the 10th minute mark, I will remind you that the time is up. The session will be followed by a Q&A session. There will be a 15-minute time limit for the Q&A session for each presenter, but can be extended to 20 minutes if needed. I kindly ask all attendees to hold their questions until the Q&A session after each presentation. If a presenter is not ready to present within 1 minute of their scheduled time, we will proceed with the next presenter. The presenter who was not ready will be rescheduled to the end of the session after all other presenters have finished. And during the presentation session, non-presenters are advised to mute their microphone unless they are permitted to speak. And please make sure that you are using the official virtual background provided. This helps maintain a consistent and professional setting throughout the session. Mr. Rafian, okay. Now, without further ado, let us welcome our first presenter, Mr. Rafian Ramadhani from Telkom University. He will present a paper titled Analyzing Issues and Challenges in Standard LMS Functions and Evaluation Methods. Please give a warm welcome to Mr. Rafian. You have 10 minutes. The screen is yours.
My presentation slide is shown in Zoom.
Yep.
Okay. Okay, I will start the presentation. My research is analyzing issues and challenges standard LMS function and evaluation method. Me, Ridwan Andrianou, in presenter of the day. The first, I will tell about the background. The COVID-19 pandemic has significantly transformed the educational landscape, highlighting the crucial role of learning management system in facilitating remote learning and as educational institution adapted to challenge the post-pandemic. The important LMS increase serving as essential platform for delivering content, managing assessment, fostering communication between educator and student. The shift toward blended or on-site learning model necessitates identification of challenges the problem needs be addressed, optimize the effectiveness of LMS. By understanding this challenge, institution can enhance the learning experience, ensuring the both educator and student can navigate complexities to modern education successfully. And this research method, I use a systematic literature review for research studies that have been conducted. And second, so the mapping and later use reference for LMS developer to make application implemented more optimally. And this, the mapping about problem and challenge, I split become three problems for classification functionality of LMS. The first is user experience in interaction, and second, system and content management, and the third is infrastructure and security. And this user experience and interaction, the first is usability. Usability refers to how easily user can navigate and operate the LMS, impacting the overall learning experience. User-friendly interface is crucial for effective engagement. And the second, interactivity involves the degree to which user can engage the content and each other within the LMS, like interactivity, foster collaboration, and enhance the learning process. And the third, accessibility ensures that all users, regardless their capabilities circumstance can effectively use the LMS, this including providing equal access to research and support for diverse learning needs. And the fourth is customization, allow user tailor the LMS to their specific needs, preference, enhancing the learning experience by providing relevant content and tools in LMS. And in system and management content, the first is content management. Content management refers to the organization, storage, and delivery educational materials within LMS effectively. Content management ensures resources are easily accessible and up to date. Example is a learning platform. And the fourth, and the second, assessment and evaluation. Assessment and evaluation involve the tools and methods used to measure student performance and learning outcome with LMS. This help educators track progress and identify areas for improvement. And the third is analytic and reporting. Analytic and reporting provide insight into user engagement and performance metrics, enable educators to make data-driven decisions, enhance the learning experience. And the fourth is integration and capability. Integration capability refers to the LMS ability to connect with other system, tools, or application, enhancing its functionality and providing seamless user experience. And in the next functionality is infrastructure and security. The first is scalability. Scalability indicates the LMS capacity to accommodate a growing number of users and content without compromising performance, ensuring it can adapt to changing educational needs. And the second is performance and reliability. Performance and reliability are assess how well the LMS operate under various conditions, including load times and uptime, which are critical for maintaining user trust and satisfaction. And the third is security and privacy. And security and privacy involves protecting user data and ensuring compliance with regulations, safeguarding sensitive information from unauthorized access. And the fourth is cost effectiveness. Cost effectiveness is evaluate the overall value of the LMS in relation to its costs, ensuring that it provides beneficial return of investment for educational institutions. And this is mapping about evaluation method is usability. The developer can use the system usability scale, and interactivity can use community inquiry framework, and accessibility can use a web content accessibility guidelines. And next is in customization, user explain questionnaire can be used. And next is CMS, content management system. Quality matters QM rubric for evaluating, and assessment and evaluation can use learning analytic for evaluating. And next, integration capability, learning tools, interoperability, LTI. And next, scalability and performance can use performance testing or load testing. And next, in security and privacy can ensure with ISO and IEC 2001. And next is cost effectiveness. They learn and McLean information system success model. And this conclusion is the first is significant role of LMS. LMS support distance and blended learning with flexibility, efficiency, and accessibility. And the second area for improvement, accessibility, data security, and cost efficiency need further enhancement. And the third, regular evaluation, the periodic update and evaluation are essential to meet dynamic learning demands. And the fourth is development opportunities. The room for innovation remains vast for LMS developers to address challenges and optimize functionality. And five, recommendation focus on interactivity features and integrating technologies for better LMS efficiency. Yes, and that's all from my session. Thank you. I back to moderator.
Yeah, thank you, Mr. Rafian, for sharing your work. If I will open the Q&A session. If you have any question or have anything to discuss with Mr. Rafian about his work, feel free to ask anything. Feel free to discuss anything. This is not a final project presentation, so it don't need to be too tense. This is a conference. If there's no one that would like to ask any question, then I would like to ask you a question, Mr. Rafian. Is that okay? I would like to ask you a question. Do you I would like to discuss something actually. Do you test the Telecom University's LMS as part of your work?
Yes, true. So Ridwan, I'm used the method is action research to evaluate perform for student in in learning in hukum etika civil.
And about the performance, or according to what you test on the LMS, what is the most important part of the Telecom University's LMS that needs to be fixed? Is it the performance or the features? I think what's the most important part?
So the most important is about content management system, because student uh, usually assess more assessment assessment comparing with material study material. If at assessment can 100 100 access, but material for studies just 10 or 40, like that. Yes, in content management system, in especially is study materials for which means the Indonesian call materi. Okay, like that.
So the most urgent aspect that needs to be fixed on the Telecom University's LMS is the content management. And I would like to ask a follow-up question. And we all probably know that the Telecom University's LMS is have a really poor performance. It's really slow. It's like common knowledge nowadays. Do you have any tips or tips on how to solve the problem
Maybe for
according to
daily,
your research?
okay, maybe for daily LMS is safe for access. No, maybe the performance is still safe, but is in last assessment in last semester, more student more access in LMS and become crowded the system, and the solve is maybe split about assessment split about assessment time for test, and we must create about feedback for Celoe, in which means is managed LMS system. That's my question, Mr. Ridwan.
Do you have any technical tips on how to solve like the performance issues? Like as we all know, the LMS is really slow and it's hard to access. When you even when you log in, it's really slow. If you want to access a video, it's also slow. For some reasons, do you have any tips or advice on that part?
Okay, okay. Maybe the LMS management must compress the file is upload for lecturer or student. Maybe use a link and not a file, because a file is big and link is just a text, and that's small and can use simple technical tips for learning management system management. Okay,
Yeah.
that's my answer, Mr. Ridwan.
Like interesting field. Thank you very much, Mr. Rafyan. Is there really no one that would like to ask a question? If so, then I think we will continue to the next presenter, which is Mr. Tamsir Sirait from Bina Nusantara University. I would like to present a paper titled Challenges and Recommendations for Improving Logistic Skills Through Simulation-Based Learning Technology. I have 10 minutes. The screen is yours.
Okay, thank you. Good afternoon. I would like
Good
to
afternoon.
present my presentation. Sorry. Is it okay? Is it okay for my presentation?
Yep, it's visible.
Yeah. Okay, good afternoon. Hello, my name is Tamsir Hasudangan Sirait. I will present my research on the topic challenge and recommendation for improving logistic skill through simulation-based learning technology. And the current agenda consists the introduction, theoretical background, methodology, research and discussion, and recommendation and conclusions. As in the introduction, this research is directed to the problem experienced by Indonesia. Indonesia is currently experiencing a decline in the Logistic Performance Index or LPI, specifically on the competence and quality of logistic aspect from 3.1 to 2.9. Then, for the overall LPI index in the Indonesia ranks position from 70 to position 45. For several observations, this is triggered by one area, namely lack of experts who have sufficient competence in the field of logistics. This is a challenge for university, in this case institution that produce graduates, especially educational institution in the field logistics, in the current industrial era 4.0. And another challenge is how to carry out logistic learning in Generation Z. To carry out the logistic learning, of course, it cannot be separated from the use of tools such as simulation. The use of simulation can make it easier to replicate real logistic process simulation into the system that can be studied in class. This simulation can also help in making it easier for students to engage so that the learning process can be easily understood, including the development of the skills. There are several types of simulation for learning, namely experience learning, problem-based learning, and situated learning theory. To conduct the more complete investigation, this research needs to conduct literature review process to look at previous research related to the use simulation for logistic learning. In this process, we use PRISMA method, where there is process consists of one, identify all literature from database use. Second, screening include delete duplicate files and unused files. The third, make a selection regarding the literature use. The fourth, analyzing and synthesizing the finding. In this process, the literature use was 30 papers. From the finding, there are several study programs that organize logistic learning, starting from a study program that organized logistic learning, starting from industrial engineering, logistic and supply chain, information system, arts program, industrial technology program, engineering program, Department of Cybernetics and Artificial Intelligence, business program, STEM education, and management program. In this study program, learning logistics intended to equip students to be ready to enter the world of work or industry. Many of simulation used to study logistics based on the use of computer, where the use of computer is more efficient in helping the learning process. From the finding related to simulation component for logistic learning, there are several components that need attention in simulation development, namely interactive, that impact to improve knowledge experience. The second is scenario-based, impact to decisions making skill, understand the complexity. And the third is gamification, that impact to the fun and knowledge and skill. And then data-driven, understanding concept of logistic problem, decision-making, collaboration, enhancing teamwork, role-play, increasing skills and knowledge by playing various roles, communication, able to complete the assigned tasks, and last is hands-on experience, improving skill and knowledge with hands-on experience. Important, beside of the component of the simulation, we found technology that important element that need to consider in development simulation for logistic. Namely, number one is database, the impact to understanding logistic with realistic data. And the second is web interface, increasing understanding motivation, augmented reality or virtual reality, learning more interactive and immersive. The fourth is application software, improve student understanding from concept theory. Big data, able to understand business with big data. And the last is IoT, able to make in case weather prediction. From the collected paper, there are three types of tools that use in learning logistic, namely use computer-based simulation by 87%, AR/VR by 6%, and the use of board games, traditional tools for logistic game by 7%. From the result, it can be seen that the use of computer-based simulation is the best choice among all the tools that used by university. So after we found a component of simulation and the technology, and then to answer the challenge, we make the conceptual model for solution. The new concept model in which the simulation model is divided into three phases. Preparation phase, learning process phase, evaluation phase. The preparation phase will refer to the skills and competencies needed in Indonesia Industry 4.0, the Indonesian National Quality Qualification Framework, level 6, the new curriculum and feedback from previous learning. At the learning process stage, scenario aligned with skill and competency enhancement will be used along with the use of game models and realistic business data, as well as appropriate technology to enhance the learning experience. Still at the learning process stage, the process monitoring student performance will be scheduled to monitor each student performance, as well as anticipate possible student learning failures. In the term of learning support technology, relational and also non-relational data model can be used to meet the needs of more comprehensive data analysis. In addition, to enhance the learning experience, web-based interface such as 3D and virtual reality can be used to improve the learning experience, especially for Generation Z. In the final stage, all the learning outcomes will be measured, including performance, motivation, engagement, skills, and competence. And the conclusion is for logistic learning that is suitable for Generation Z, a computer-based simulation is needed, which is in accordance with the needs of the Generation Z who prefer visual-based learning. The use of computer-based simulation and addition of game model can help in learning logistic that are complex and make it fun. Learning adoption of the last technology in logistic learning makes logistics learning in accordance with the needs of Industry 4.0. The this conceptual proposal for learning logistic learning simulation can be realized into application prototype, namely a computer-based simulation, which will be a much more comprehensive tools to improve the quality of logistic learning. Of course, this computer-based situation simulation model has a limitation, namely the need for more complex architectural model to accommodate all the technology that you will use as a part of overall simulation to be built. And the last is we know we have to write the future research. It's necessary to analyze all the technology used to develop prototype that are more in line with the needs of university, including investment analysis of the technology to use. And this is all of part of the references. And this is the end of presentation of this research. Thank you. Thank you for attention.
Thank you very much, Mr. Tamsir. I will open the Q&A session. If anyone have any question, please feel free to ask Mr. Tamsir. I guess no one have any questions. So then I really have to find a question. It's a comment from the community. I would like to ask a question, Mr. Tamsir, about
Yes.
the percentage of the use of VR or AR on the teaching of logistics. As you can see, it's only a small percentage, about 6% from your presentations. Do you expect that number to grow because AR and VR is kind of relatively new on to be used on education? So do you expect that number to grow? And do you expect to also use that technology for education?
Yes, currently we know most of the university in Indonesia use the oldest tools. It is very, very old, like beer game. And after we do a study, they are found challenge. So how to teach the logistic in old tools? So we realize that the student that we teach now is Generation Z. They are visual-based learning. They are refer to the visual, and they are we can increase the motivation with what they interest. So this research, this is the challenge for us, the university, to found the new model, the new tools that can, let's say, motivate them to engage learning the logistic course. Because we realize the logistic course is not, we namely is complex, the complex topics. Yeah, they also learn from how to prepare from the inventory, how to prepare the production, how to prepare to the distribution, and also how to make sure all the product make it simple and need to time to market is very, very very good. That's why we need we need more we know the VR is not it's expensive. Yeah, you know, VR is very expensive, but we can after we have the investment, we can do that. Not all the university in Indonesia have the good investment on it. So my answer is we hope the use of VR that related to Generation Z is more growing more from 6%. But the other side, the university have to prepare the money investment for it. Yeah, that's the reality for now. So yeah, I think it's the university have to choose it for to increase the quality of our learning course. Thank you.
Okay, that's interesting. Yeah. We should consider the budget of the university as well.
Yeah.
That's interesting. Anyone else want to ask any question before we proceed to the next presenter? Or I guess not. Then I'll continue to the next presenter. Let's welcome Ms. Bintan Arta Mevia from Telkom University. They'll also present her paper about depression detection using hybrid model BIL-STM, CNN with GLOVE as feature expansion in X. The screen is yours. You have 10 minutes.
Okay. Is my voice audible?
Yep.
Okay, thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Bintan Artamevia, and I am very honored to present our research on depression detection using hybrid model BLSTM-CNN with GLOVE as feature expansion in X. This study is my collaborative work between myself and my colleague, Mr. Erwin Budi Setiawan. And before diving into the details of our research, let me walk you through the structure of this presentation. And we will begin with introduction, proposed method, experiment result and discussion, and also the conclusion. First, let's jump into the first section, which is the introduction. Depression impacts millions globally and is a leading cause of suicide. And traditional diagnostic methods are slow and also stigmatized, which making it difficult for people to seek help. Social media platforms like X, or previously we called Twitter, offer real-time insights into mental health through users' posts. However, most studies focus on English content and leaving a gap in analyzing Indonesian language data. Current methods also often lack hybrid approaches that combine traditional and deep learning technique for better performance. Therefore, we propose a hybrid deep learning model to analyze Indonesian tweets using TF-IDF, GLOVE, and a BLSTM-CNN architecture to improve detection speed and accuracy while reducing stigma. To dive deeper into our research, let's talk about the proposed method. We start with the raw dataset that will be labeled based on whether it relates to depression or not. And next, we will continue to split our dataset into training and testing sets, and both of them will go to the pre-processing step. Then, the feature extraction and expansion is performed using TF-IDF and GLOVE, and also the training data will be trained, which will be evaluate their performance using the test dataset. And the final depression detection model is selected based on accuracy. Let's hop onto the first step from the proposed method, which is data crawling. And in this step, we collect textual data from X that written in the Indonesian language and span from 2020 to 2024. Ensuring the dataset reflects recent language usage trends. And to focus on depression-related content, we use specific keywords indicative of mental health struggles, examples including capek, meaning tired, and others like gelisah, lelah, putus asa, sedih, and more as shown in the table on the right. Additionally, the word cloud on the left visualizes the most frequently appearing terms in the dataset. further demonstrating the prevalence of emotional and mental health related vocabulary. And after that, we label the data manually using a majority vote system, which involves multiple annotators. As shown in the table, our data set contains a total of 50,000 tweets that evenly distributed between subclasses, which the first one is depression, which represented by the label 1, and the second one is non-depression, which represented by the label 0. Then the next step is data preprocessing. The steps include our data cleaning, which to remove unnecessary symbols to simplify the text, then case folding to convert all text to lowercase to standardize the data, and after that is normalization to replace the non-standard word to the standard form based on Indonesian Dictionary or Kamus Besar Bahasa Indonesia. Then we split the sentence into words or tokens in tokenization. And we also eliminate the unused and meaningless words through the stopwords removal step using an LCK library. And finally, we do the stemming process using Sastrawi library. And after that, we employ term frequency inverse document frequency or TF-IDF for feature extraction. The picture on the right side presents the mathematical equation on how TF-IDF is calculated. The first one is term frequency or TF. It measures how often a term appears in a specific document, and the IDF or inverse document frequency responsible for the rarity of a term across the entire corpus. The next step, we utilize GLOVE or global factors for word representation to expand features. The corpus used was built using Indonesian news articles, or we call Indo-News data, and label tweets from our datasets. The table on the right side shows the example of the 10 words most similar to the word sedih or sad in English. Then, after we expand our features, we move on to the model called bidirectional long short-term memory, or we will continue called as BLSTM. In this step, the BLSTM units and dropout layer were obtained by manual tuning method and got the best result with 128 units and 65% dropout layer. And the model's architecture is as shown on the right side. After we explored the BLSTM, we also integrated convolutional neural network, or we will continue the CNN. And the process of the hyperparameter selection in this model is also using manual tuning and got the best result with 32 units and 20% dropout layer. Therefore, the model architecture is also shown in the right side. After utilizing BLSTM and CNN individually, we combine them to create a hybrid model. And in this hybrid model, we did not optimize the units and dropout layer anymore, but we tuned the learning rate value and got the best result at 0.00001. After we explore the proposed method, let's move on to the result and discussion of this research. And this research was conducted with a series of experiments and were divided into 4 scenarios as shown on my screen. Let's dive deeper to the first scenario. In this scenario, we experimented the different train test split ratio to find the optimal configuration for model performance. The result is summarized in the table. And based on the table, we can see that the 90 and 10 split ratio consistently provided the best accuracy across all models. And so we conclude that this split was selected as the optimal configuration for this experiment and will be used in the next scenario, which is the scenario 2. And in this scenario, we evaluate various n-grams configurations for TF-IDF. And the result is as shown in the table also. We can see that the unigram bigram or 1-2 configuration yielded the highest accuracy for the BLSTM model, followed by the BLSTM CNN. And the larger n-grams such as bigram or 2-2 and 3-gram or 3-3 showed significantly lower performance, likely due to their inability to generalize with the limited data. And same as before, we will select the best n-gram configuration on each model to use in the next scenario. On the third scenario, we evaluate the different maximum features values for the TF-IDF. This table shows the result of the current scenario. We see that the BLSTM model achieved its highest accuracy with 25,000 max features, And this showed that BLSTM benefits significantly from a larger number of features. And these findings highlight the importance of tuning the number of features to balance model complexity and computational efficiency. The configurations for the TF-IDF maximum value will be used on each model to the next scenario. And finally, on this last scenario, we explore feature expansion using GLOVE word embeddings. We tested 3 different corpus such as Twitter, Indonesian news, and a combination of both. Each corpus was evaluated with the top 1, 5, 10, and 15 similar features. As we seen on the table, the BLSTM model consistently outperformed others, achieved the highest accuracy using the Twitter corpus with the top 10 features. After we conducted all the scenarios, we also analyzed the scenario significance by the accuracy improvements across the scenarios using hypothesis testing. And these results that are shown in the table highlight that while some transitions between scenarios like scenario 1, 2, and 3 did not yield significant changes, the cumulative improvements from scenario 1 to scenario 4 were statistically significant, and that validating the efficacy of our methodological enhancements. And finally, we move on to the last section, which is the conclusion. After all the scenarios conducted, we can see that BLSTM consistently outperformed other models across all scenarios, achieving the highest accuracy in 84.2%, followed by the proposed model, hybrid BLSTM-CNN. These results show that BLSTM and BLSTM-CNN reach a high increase compared to the baseline model. As shown in the chart, BLSTM and BLSTM-CNN exhibit significant improvements across the 4 scenarios. The peak accuracy for BLSTM was observed in the scenario 3 and with a slight drop in the scenario 4 due to irrelevant or redundant features in the expanded corpus. And conversely, CNN and CNN BLSTM hybrid model maintained consistent but lower accuracy compared to the other models. And from this research, we conclude that rather than other models, BLSTM achieved the highest accuracy due to its excellent performance in capturing the sequential data and learning contextual information from both past and future. Okay, I think the time is up. That's all from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for sharing your work, Bintan. I will open the Q&A session. Is anyone would like to ask a question? I have a question from Muhammad Faisal, and I'll prioritize the participants that are raising their hands first, compared to the participants that ask from the chat box. So you can go ahead. The name is cut off. Ali.
First, thank you.
Alicia.
Okay.
Alicia, you can go ahead and ask your question. Alicia.
Okay. Thank you for the opportunity. My name is Alicia Kristina Parinusa from Telkom University. I have a question. Your research focused on Indonesian language depression detection. How well do you think this model generalized to other language, and could it be adapted for multilingual application? Thank you.
You can go ahead and answer the question, Bintan.
I will answer the questions from Ms. Alicia first. Thank you for your question, and that's a very great question because I think generalizability is a critical factor in any NLP or natural language processing model. And our model was indeed specifically designed for Indonesian language depression detection, but the methodology can certainly be adapted to other languages. And I think the key component that would need modification is feature expansion using GLOVE because word similarity relationships are language dependent. However, if we replace our Indonesian corpora with multilingual embeddings or language embeddings, the same approach could be applied to detect depression in other languages. And I think, moreover, transformer-based models such as MBERT or multilingual BERT offer a direct path for generalization, because instead of training a new model from scratch, we could fine-tune these pre-trained multilingual models using our methodology while leveraging cross-lingual transfer learning. And I think this would allow the model to detect repression symptoms in multiple languages. I think that's all from my answer.
Is the answer from Ms. Bintan satisfactory? Alicia?
Okay, enough. Thank you.
Okay, and I'll move to the next question. Afra, go ahead.
Oh yeah, thank you for the opportunity. I would like to ask about the BLSTM. Given that BLSTM outperformed the BLSTM CNN hybrid model, what factors do you think contribute to this result, and does it challenge the effectiveness of hybrid models in NLP? That's all my question. Thank you.
Okay, thank you, Ms. Afra, for your questions. I think this a very good questions also, because hybrid models typically enhance performance by combining two individual models like CNN and BLSTM in this case. But in our study, BLSTM alone achieved the highest accuracy and slightly surpassing the hybrid model. And as I said before, this may be due to several factors. And the first one is the redundant or irrelevant information when applying glove embedding, which affecting CNN's ability to extract meaningful patterns. And the second one is because BLSTM captures the sequential and bidirectional context more effectively rather than CNN that highly effective in image processing. I think that's all from my answer. Does it satisfy your question, Miss Afra?
Yes, that's enough. Thank you, Miss Binar.
Okay.
Okay, go ahead. Next question, Shifa. You can go ahead and ask.
Okay, thank you for the opportunity. Okay, I will ask some question to Bintan. What makes your approach unique compared to previous depression detection studies?
Okay. Thank you, Ms. Shifa, for your questions. Because I think it's very important question, because depression detection using NLP has been widely explored, but for my research, there are key aspects that differentiate our approach. First, most previous studies focus on English language datasets, but our research tackles Indonesian language depression detection, which presents unique challenges such as slang usage, word abbreviations, and informal structures in Indonesian language. And to address this, we applied extensive text processing techniques, including normalization using Kamus Besar Bahasa Indonesia Dictionary. And the second one, the prior research has experimented with either BLSTM or CNN individually, but the hybrid BLSTM and CNN is rarely explored to this topic, depression detection. And additionally, we also introduced glow feature expansion, which has not been applied in Indonesian depression detection before. And I think by constructing custom word similarity corpora from both social media and Indonesian news articles, we have improved feature representations for rare and complex words. I think that's all from me. Does it satisfy your questions, Ms. Shifa?
It's very clear. Thank you, Ms. Dinar.
Okay.
You can go ahead and answer the question from Mr. Muhammad Faisal. Bintan?
Okay. I think thank you for your questions, Mr. Muhammad Faisal. And unfortunately, our research does not analyze the average age for respondents who desperate, but we limit our data sets from 2020 to 2024 and use use certain keywords that indicated depression, because this depression condition is, we all know that this is not a condition where affecting a certain age, but it's generalized detect to all people. So we did not the average age for respondents to desperate. Does it satisfy your questions, Mr. Muhammad Faisal? Okay.
Okay. Is there anyone else to ask a question? If not, then we will continue to the next presenter. Thank you very much, Minta.
Okay, thank you.
Continue to the next presenter, which is Ms. Afra Prasetyawati from Telkom University. Her paper is about analyzing of the alignment between course learning outcomes, or CLOs, and program learning outcomes, or PLOs, using textual similarity-based methods. The screen is yours. You have 10 minutes.
Thank you. I will start my presentation. Okay. So good afternoon, everyone. My name is Afra Prasetyawati. So today I will present my paper titled Analyzing of the Alignment Between Course Learning Outcomes, or CLOs, and Program Learning Outcomes, or PLOs, using textual similarity-based method. With me as the first author, and Ms. Werihis Fenli Saragi as second author, Ms. Mariana Frima as third author, and Ms. Ade Romadhani as fourth author. This is the content list that I will present now. There are introduction, related works, methods, also result, and analysis. Let's start the presentation with introduction. So the background from our paper is about the condition of education in Indonesia that's constantly changing to continuously improve the quality of education itself. One of the level of education in Indonesia is universities. Universities, as the pinnacle education system in Indonesia, must prepare its students' competencies to be ready to enter the workforce by providing good quality of learning activities. So to prepare for this, university, especially faculties and study program, prepare curriculum as a guide for the learning plans for students. And from the curriculum, the study program will create CLOs and PLOs. So what is CLOs and PLOs? Simply, CLOs and PLOs is the guidelines formed by the study program to determine the graduation competencies of students in a course. And from the CLOs and PLOs pairs, the concern raised in our paper is about the misalignment between CLOs and PLOs pairs that are manually created by the staff. So to address this issue, our study developed a practical system to analyze the alignment between CLOs and PLOs pairs using textual similarity-based method. So what is textual similarity-based method? Textual similarity-based method is an instrument in NLP that are usually used in NLP tasks, one of which is document checking. By the study by Wang et al., the measurement of textual similarity is divided into two, namely text representation and text distance. And in our study, we use TF-IDF and FastText as method for the text representation and cosine similarity as method for the text distance. Next is related work. So our study is inspired by study by Zaki et al., which developed an NLP model to analyze the alignment between CLOs and PLOs. This research built the NLP model to solve the problem of manual mapping of CLOs and PLOs. NLP was chosen because it can effectively handle text-based data. Based on the study by Zaki et al., TF-IDF can represent the words and shows a good result with the accuracy of 0.8306. However, TF-IDF has a drawback in capturing the semantic relationships between words in sentence. Therefore, FastText is used in our study as the comparative method. So here is the model architecture of FastTech. So FastTech will process word representation that have been separated based on their n-grams located in the input layer, and then calculates their representation vectors in the hidden layer, and finally outputs the representation vector through the output layer. After obtaining the TF-IDF and FastTech vector result, their similarity is then calculated using the cosine similarity method. Why we choose cosine similarity? Because cosine similarity providing high accuracy and not limited by the length of the sentence. Next is method. So this is the flow chart that we use in our paper. So we collect the data set, then do the data preprocessing, then calculate the TF-IDF and FastTech vectors, and then calculate cosine similarity. And the last is evaluate the cosine similarity and the model performance. This is the data set that we use in our paper. So this is the example of the data set. We collect the data set from RPS in 2020 curriculum from informatics study program. And so what is RPS? RPS is a document created as a guide for the learning plan over one semester in a course. This is the data pre-processing that we have done. We removing stop words, removing punctuation, lower casing, and stemming. This data pre-processing that we have done is to enhance TF-IDF perform. So TF-IDF can only focusing itself to analyze words and improve TF-IDF accuracy. Next is evaluation. We evaluate the accuracy of the cosine similarity result. We also set category based on the threshold for the similarity value. So we have two category. There are aligned and not aligned. So CLOs and PLOs said to be aligned if the cosine similarity value is equal or above the threshold, and said to be not aligned if the cosine similarity value is below the threshold. This is the equation for threshold and accuracy. So next is result and analysis. So from the TF-IDF model, we facing difficulties at the accuracy. So we have to change the parameters of the TF-IDF model so the models can achieve higher accuracy. The first parameter that was changed is max_df to 0.8, which means words that appear in more than 80% of the documents will be ignored. Then min_df of 5 means that if words appear in fewer than 5 documents, those words will be ignored. And finally, we change the n-gram range into unigrams and bigrams. Okay, in the figure 3 is the highest and lowest result of cosine similarity in TF-IDF. So from the TF-IDF model and cosine similarity calculation, we can achieve the highest accuracy of 0.144. This is the best result that we can achieve after modifying the TF-IDF parameters. This low accuracy can happen because the dataset has a lot of word variation. From the highest cosine similarity result obtained is 0.546. We analyzed that PLOs and CLOs pairs had the highest cosine value because the changes in the TF-IDF parameters cause the word corpus to become smaller. Words like can, write, which have high TF-IDF value, appear in both documents and cause the high cosine similarity value. And from the lowest cosine similarity value that is 0, we analyze that there are no identical words appearing in both documents. So the TF-IDF value is 0 as well as the cosine similarity value. This is the highest and lowest result of cosine similarity in FastTech. From the FastTech model and cosine similarity calculation, we can achieve the highest accuracy of 0.9375. This proves that FastTech can provide better analysis result than TF-IDF. The highest cosine similarity result is 0.927, as shown in figure 4. We analyzed that this pair of PLO and CLO both involve aspect of software development, whether through intelligent system or in general. In the CLO section, it mentioned the software development life cycles, which is part of building intelligent system. And the lowest cosine similarity in FASTEC is in 0.491, and we analyzed that the pair of PLO and CLO does not have a harmonious meaning. In PLO, the focus is on the broad application of concept related to entrepreneurship and business, which not align with the focus of CLO that explain the meaning of leadership and time management. So next is the conclusion. So the conclusion from our research, the first one is FASTEC represent the alignment between CLOs and PLOs better than TF-IDF with an accuracy of 0.9375, while TF-IDF has an accuracy of 0.144. TF-IDF is less effective in representing the text well in this dataset because this dataset has a very diverse range of words. TF-IDF is entirely depend on the distribution of words in the dataset. Meanwhile, FASTEC can pay more attention to the semantic relationship between words in the word text representation process and can handle words that rarely appear in words corpus, proven by the higher accuracy of FASTEC as the text representation method that can better understand text based on its semantic relationship compared to TF-IDF, which only consider word frequency in the document. So that's all the presentation about our paper. Thank you.
Thank you, Afra. No one wants to ask a question? Shifa, you can go ahead and ask. Go ahead, Shifa.
Okay, thank you for the opportunity. I want to ask one question to Afra, Mrs. Afra. Okay, why do you choose fast text instead of the other words embedding methods? Because I think fast text is an older method than any other method. Okay, thank you.
Okay, thank
Clear,
you,
Afra?
Miss.
Mrs. Afra?
Oh, yeah.
Okay.
Yes. Okay. I will answer your question. Thank you for your question. So I choose FASTEC to be the word representation, text representation process because based on study by Tosevka et al., FASTEC has shown better performance compared to GloVe, LegVac, and ConceptNet. Also, the FASTEC has better performance compared to TF-IDF with PCA in the study by Khan et al. And moreover, because our data set contains a wide variety of words, FASTEC was chosen because according to research by Zazan et al., it is more effective in handling lexical diversity in sentence if we compare to the TF-IDF method. Is that answer your question?
Is it clear, Mrs. Afra? Thank you very much.
Yes, thank you, Ms. Siva.
Okay, go ahead. Continue to the next question from Luthia. Luthia?
Okay, thanks for allowing me to ask. Ms. Afra, I'd like to know that why do you choose threshold in the evaluation step?
Okay, thank you, Ms. Lutfia Sania, for the question. So I choose to use threshold because this approach can enable the automatic classification of aligned and not aligned CLOs and PLOs based on the cosine similarity values, and the threshold serve as the limitation that determines whether two texts have a high enough level of similarity to be considered aligned. And with the threshold approach, we can make the decision about alignment can be met more objectively and consistently without relying on subjective manual interpretation. Is that answer your question?
Yeah, it is clear. Thank you, Ms. Afra.
Okay, thank you, Ms. Lutfia Sania.
Okay, we move on to the next question from Athalia. Go ahead.
Thank you for the opportunity, Miss Afra. I want to ask,
You mentioned in your study literature that you are inspired by Zaki et al. For your research. Can you explain why do you inspired by their research? Thank you.
Okay, thank you, Miss Atalia. So, our study is inspired by study by Zagi et al. Because we share the same concern regarding to the misalignment between CLOs and PLOs, which are manually created by staff. And additionally, our study further develops to the text representation approach by incorporating FastText as the comparative method in the text representation step. It is clear enough, Miss Adalia?
Yes, Miss Afra. Thank you so much for the answer.
Okay, thank you, Miss Adalia.
Thank you. Move on to the next question from Shabila. Go ahead. Shabila.
Okay. Okay, thank you for the moderator. I will ask to the Mrs. Afra. Is the importance of the alignment between clause and flows in your research? Thank you.
Okay, thank you, Miss Shabila, for the question. So the importance between CLOs and PLOs to be aligned with each other, because based on the research by Mahajan and Singh I'm sorry, because Mahajan and Singh was said in Puspita research, CLOs has several roles, like it can help facilitate a university in conducting learning activities, helps lecturers plan learning activities for one semester, and assist university in assessing whether the course has achieved its objective. And therefore, this is very important for the pairs of PLOs and CLOs to be aligned one each other, because CLOs are an extension of the description of PLOs that will be directly applied during the learning activity. So, is that clear enough, Miss Shabila?
Okay, that's clear. Thank you, Afra.
Okay, thank you.
We still have 4 more minutes. Go ahead, Ms. Bintan, and ask your question.
Thank you, the moderator, for giving me the opportunity to ask the questions. I would like to ask Ms. Afra on why do you choose the accuracy in the evaluation steps, Ms. Afra?
Okay, thank you, Miss Dinar, for the question. So, I choose accuracy because accuracy is used to assess how well the text representation method, which TF-IDF and FastText, generate appropriate representation. Since the main objective of this study is to compare the effectiveness of these two methods in representing the alignment between CLOs and PLOs, accuracy serves as the suitable evaluation metrics to measure how well the model distinguishes between aligned and not aligned pairs based on the predefined threshold. Is that answer your question, Miss Dinar?
Yes, I satisfied. Thank you, Ms. Afra.
Okay, thank you.
Thank you, Bintan. Is there anyone else who would like to ask a question? If not, then we will continue to the next presenter. Let's welcome Mr. Muhammad Diego Brilliant from Gajah Mada University. That would like to present the implementation of knowledge management for enhancing employee competence. The screen is yours. You have 10 minutes.
Thank you. May I play my presentation video, Mr.?
No worries.
Okay.
Sorry, Mr. Rige, we can't hear the audio. It's not audible, sorry.
Sorry.
We can't hear the audio. I think it's in the settings. You can check the share audio as well.
Oh, well,
We can't hear the video, sorry.
okay. Good afternoon, everyone. Let me introduce myself. My name is M. Diego Brilliant from Department of Electrical and Information Engineering at Gadjah Mada University. I will be presenting research conducted alongside my colleague, Lukito Edi Nugroho, from the same department. Our study is titled The Implementation of Knowledge Management for Enhancing Employee Competence. We appreciate this opportunity to share the innovative solution we have designed to address employee competency challenge. The energy sector faces challenge from rapid technologies advancement and operation demand. PT PLN Nusantara Power UPK Sibaleng struggles with inefficient knowledge transfer, slow employee adaptation due to frequent job rotation and ineffective competency certification. To address this, a knowledge management system is proposed to streamline knowledge transfer, improve employee adaptation, and enhance continuous competency development. This solution aims to resolve this challenge effectively. Okay, the research objective. The research focus on 4 objectives. The first, enhancing employee competency by providing structured knowledge, improving knowledge transfer efficiently through centralized access, and next, ensuring compliance with industry regulation by progress tracking and fostering a culture of continuous learning to motivate skill development. This is a methodology. The methodology consists of 4 steps: data collection through questionnaire and interviews and observation to understand workflows and knowledge transfer. The next, data analysis use descriptive methods and PLS to assess the impact of KMS on competencies. And the KEMS was developed with feature like a centralized repository, role-based access forums, and competency tracking. The system was created using SDLC, including planning, development, testing, and updates to meet organization needs. This is result and the discussion. The implementation of KEMS reduce knowledge transfer time by 15% from 4 weeks to 2 weeks. This was achieved through centralized access to information, allowing new employees to learn independently and easing the burden on senior staff. This improvement enhance organization productivity by accelerating employee adaptation. And then this research demonstrates that the implementation of knowledge management system improve task understanding from 65% to 88%, and technical competency from 70% to 85%. This was achieved through structured access to information and role-based training, which accelerate learning and enhance employees' readiness to perform their tasks. The results show that the implementation of knowledge management system achieve high user satisfaction levels. 90% of users were satisfied with the ease of information access provided by the system. Additionally, 85% of users appreciate the collaboration feature in KMS, such as discussion forums and knowledge sharing. This high satisfaction rates highlight the effectiveness of KMS in meeting the organization information and collaboration needs. This is a dashboard knowledge management system menu. The KMS dashboard offer intuitive navigation with key features such as centralized knowledge repository, competency standard, job description, and discussion forum. Users can efficiently search, view, and add new documents, enhancing knowledge transfer and collaboration. This is a standard competency menu. For example, main competence, there are adaptability, descriptive knowledge for level 1, knowing the basics or principal knowledge methods tools regarding competency knowledge. Okay. This is a job description. This dashboard display jobs description including core field competencies and enabler field competencies, each with proficiency levels. User can view details of responsibility, job specification, and the required competency level for specific roles. This feature helps employees understand their roles, requirements, and plan their skills development accordingly. Okay, this is the dashboard display employee profiles, core competencies, job description, and feature for addressing competency gaps. This helps employees understand their roles, evaluate gaps, and receive guidance on necessary skill development. The gap fulfillment feature specifically provides recommendations such as relevant training, skill development, or strategic action to close competency gaps. This ensures employees can proactively enhance their skills to meet organization standards and align with job requirement. And then this is the conclusion. This conclusion highlights that the position-based KMS effectively enhance employee competencies and operational efficiency at PT PLN Nusantara Power UPK Sibalang. Future improvement include integrating AI for advanced analytic, enabling mobile compatibility for broader access, and implementing continuous system updates and training programs. Okay, thank you.
Okay, thank you very much, Mr. Diego, for sharing your work. I will open the Q&A session, so feel free to ask if you have any questions. I have a question from Mr. Dudik on the room chat. You might want to answer the question, Mr. Diego. Why was partial least squares used in data analysis? Yeah, good. You can go ahead and answer the question.
Okay, why I choose PLS? PLS was chosen because it well suits for analyzing complex model with multiple variables, especially when dealing with small sample size. PLS allow for the assessment of both direct and indirect relationship between variables, making it ideal for evaluating how KMS influence employee competencies. These methods help assess the impact of KMS by identifying significant predictor of knowledge transfer efficiency, competency improvement, and user satisfaction. Additionally, PLS doesn't require strict assumptions about data distribution, make it a flexible tool for analyze real-world organization data. Suppose a study aims to measure the impact of KMS on employee competency improvement. The study examines three main variables. The first is knowledge transfer efficiency, second, employee competency improvement, and the third, user satisfaction with KMS. Okay.
Mr. Duda, does the answer of Mr. Diego satisfy your question, Mr. Dudik? Sorry. Okay, we can move to the next question from Mr. Agus Haryadi. What are the biggest challenges faced during the implementation of KMS output PTPL and Nusantara Power UPK Sebalang?
Okay, thank you for your question, Mr. Agus. What are the biggest challenges faced during the implementation of KMS at PT PLN Nusantara Power UPK Sibalang? Several challenges were encountered during KMS implementation, including the first, resistant to change, employee accustomed to conventional knowledge sharing methods were initially reluctant to adapt the system. The second, integration with existing system, ensuring compatibility with other enterprise systems such as HR and operational software require technical adjustment. The third, user engagement, encouraging employees to actively use the system require incentive and a user-friendly design. And the next, data structuring, organizing vast amount of knowledge into a structure and accessible repository pose initial difficulties. And then the last, to overcome this challenge, we conducted comprehensive training, improve management to drive adaptation, and continuously refine the system based on user feedback. Okay, I think it's enough.
Okay, Mr. Agusto. So that's such a question. Is there anyone else that would like to ask a question? If not, then I would like to ask a question about your research, Mr. Diego.
Okay.
It's about the data. When you compare the employees before using the KMS and after using the KMS. Can you show that data or share your screen on that part of the presentation?
Okay, thank you, Mr. Ridwan. Okay, before I compare the KMS implementation in UPK Sibalang, PTPN UPK Sibalang, the employees cannot get a certification operational. And then with the KMS, employee can success and pass the certification operational with KMS with the menu training in KMS.
You tested the employees before and after the employees that are using the KMS and that are not using the KMS. Did you test that on two different groups or did you test that on the same group?
Different groups in senior staff and junior staff.
Does that different of the staff demographic because you tested on the senior and the junior staff? Does that affect the result, do you think?
Sorry, sir, can you repeat your
So you
question?
tested on the junior staff and the senior staff. Which one of these two groups that are using the KMS?
So junior staff can be the fast track use the KMS because many junior staff have a new position because junior staff cannot be experienced, and well, senior staff can be add document knowledge document to KMS, so junior staff can be learned in the KMS portal, sir.
Okay, thank you for your answer. I think that concludes for our presentation session. Thank you very much, Mr. Diego. And I would like to ask all the participants to turn your camera on because we would like to document our session today. So please turn your camera on, Ms. Bintan, Mr. Rafian. Actually, all participants, if you would like to turn your camera on. We will wait for Mr. Rafian just a few minutes. I think it's taking too long, so I'll just do the screenshot now. 1, 2, 3. Please smile, everyone. Give your best smile because you've just finished a conference. 1, 2, 3. Okay, thank you very much. This concludes our parallel session, our presentation session today. And on behalf of ICADEIS 2025, I would like to thank all of our presenters for their exceptional contributions and insights. I would like also to extend my gratitude to all participants for their engagement and thought-provoking questions. We hope this session has been both informative and inspiring. Please be reminded, yeah, just thank you once again, and have a wonderful day. Thank you, everyone.
Yeah, thank you, everyone.